Good morning, folks. This is the presentation in Lab 5. Uh, think about it as Lab 5, Week 5, and it still deals with the hybrid analysis. So on the agenda today is I'm going to repeat something that was done in class yesterday, but this time as an assembly instead of a single part. And then once I do that, then I'm going to do another example of a hybrid problem. Now, this is the problem that we did yesterday, and I want to repeat that, except that it's going to be done as an assembly, and I'm going to do it actually once again 2 different ways. One is with symmetry, and another one without symmetry. Okay, but as an assembly. Okay. So let's move on, and there is another problem that I'm going to do once I'm done with this, but we'll worry about it later on. So immediately we start with a product file, product, immediately save it, file, save management, save as, desktop, new folder, and that is going to be assembly, chapter, well, I call it the hybrid, okay. Let's insert the cylinder first. So first I'm going to do it without any consideration of planes or symmetry. So insert a new part in there, and I'm going to call this thing cylinder, cylinder, and cylinder. Okay, let's make it. Double click. On that plane, I will sketch circle radius 1 inch. Sorry, radius 0.5, that's what I meant, 0.5. I'm pretty sure it was radius 0.5, yes. Okay, and exit. Padded. Now, obviously, I'm in shape design, generative shape design, so we don't have access to pads, so you have to go to mechanical design, part design, and there you see the pad, height of 2 inches. Good. That takes care of the cylinder. Then I'm going to create a surface in a plane which is 2 inches above or 1 inch above that base plate. So we go up here, insert a new part, and I'm going to call this thing the plate. Put that plate, right click properties, plate, and plate. Okay, let's make it, double click on it. On a convenient plane, I'm going to create a plane actually 1 inch above that XY. And because I want to create a surface, I should really switch to shape, generative shape design. On that plane, we'll sketch. Let me remind you what we did here. So let's do the following. Actually, it wasn't like this. So let's do it like so. One can clean these up depending on, okay, good. So let's see now, the left line control, right line control, middle axis, control right. Left line, control, right line, control, middle axis. We make it symmetric. Because dimension these, I believe this was 2. This was 2. Okay. And exit. Now we can fill this. We can fill it. Here, fill, F-I-L-L. And then I'm going to make a hole there. And there are different ways of doing it. One of them is to, on that plane, on the plane of that surface that we created, we're going to project that circle and exit. And I get the saw. It says, element to cut, not sketch to, cancel. Make sure it's not something, nothing is selected here. Click on the left click so that nothing is selected. Element to cut is that surface. Cutting element is that circle that I just projected. And then you have a choice of one side or the other. Obviously, the inside is what I want to remove. And say, okay, well, that part is still there. I just put it in hiding. That's all. I just put it in hiding so you could see that there was a hole there. Okay, good. All right, let's go all the way to the top. And let's make these lines as part of our third part. So I'm going to insert, new part. And I'm going to call this thing the vertical support. Right-click properties. Vertical support. Something down here. Vertical support. You say OK. Double click. We're going to create 2 lines. So the way I'm going to do that, just like I did in the yesterday. So I'm going to make a line, point and direction. I select this point in the direction Z, starting from 0 and going all the way to 3 up. There we are. Another one, same thing. This point, direction Z, numbers are the same. Good. Okay, all the way to the top, all the way to the top. Click on the floppy so that it's stored there. And we apply material. Everything is made out of steel. So we can select, we can put it on the assembly. Very good. We're done. So now we're going to go to generative structure analysis. Katia sees a 3D object, immediately it meshes it, no problem. But these sketches are bothering me. By the way, let me see now. Where is that hide place view? I was looking for that hiding stuff here, all planes and things like that, but can't do it. Let me hide the sketch. There. And change the rendering. Okay. So we're going to mesh this with shell octi-triangle mesher or shell element, I call it. And I'll call it 0.2 linear. Okay. Give it the thickness. I believe the thickness was 0.1. I'm going to mesh this with the beam element. Fine. And also this one with beam element. And 1D property, you select the support, rectangular, the size is 0.05 by 0.05, and because it's rectangular, you cannot close until you select an orientation point. And for orientation point, I'm going to select this. We turn this thing around, and it puts it in the orientation that you want. I could have made this thing bigger so that you could see it, but believe me, that's correct. And do it again, this time for the other one, this edge, and size is correct, shape is correct, and for orientation point, I select this end, and we say OK. All right, So remember, these were clamped. This is clamped, and this is clamped. Later on, I'm going to come back and remove that clamp and do something else to it. And the bottom of this is clamped. Okay, and we put a pressure of 100 psi on that top face. And if you look at it, the direction is correct, pushing down. It said if I run this thing, it's going to bomb out. You know that. Please watch the video from yesterday's lecture, because you need connections. Point to point, bottom of this line and the corner of that surface. And again, bottom of this other line and the corner of that. And these connections must be rigid. Point to point is rigid. So we create a connection between, let me hide this so that I don't inadvertently take the wrong point, this point, and the corner of this. If you're having a hard time, you can always hide this and hide that. Vertex, this vertex. Make sure you can select that vertex. Now, if it's not letting you do that, I suggest you bring it to that face. At the end of the day, you have to select the vertex of that object. And hide that line, hide that connection, and did I take your vertex? Good. And this is going to be rigid. So let me do that right now. There's the distance connection property, rigid, on this connection that we just created. Right there. We'll come back to this transmitted degrees of freedom later on. And repeat the same thing on this side. So another connection. Let me hide this. That point. Second component. Let me bring this thing to the show mode. And I want to select that corner point. Now, if I'm having a hard time or I'm not sure, we can hide the stuff. And now I can access this. And once again, this one is also rigid, right there. Okay, the lines are there. If you want to see them, I'll bring them in the front, but doesn't matter. Okay, now I also want a connection between the face of this cylinder and the black edge of that hole. Because remember, there's also a sketch here. I don't want that sketch. So let me hide that sketch. That's the sketch. See that? Because I projected it? That's not what I want. The connection between this face and for the second component, that black edge that you see, circular edge. And this is going to be fastened. So everything is perfectly welded, perfectly fastened, or perfectly bonded. So that means fastened. Okay, so you go face-face connection property. There's a fasten here. I select that, put the fastener sign there, and run it. And it's going to work. So it looks like that. If you animate it, you can see that it's correct. The only thing is that these things are bending, and that should not surprise you, because what I'm telling you is that this end of this is welded to that sheet. If these are cables, then you have to go and do something. I told you we're going to come back. So deactivate this first of all. Go back to the properties, double click on rigid connection, and click on transmitted degrees of freedom. If it's a cable, rotation should not have any business there. The same thing with the other one. Rotation should not have any business there. If I run it, I will see that that thing does not bend down here, but it will bend up there. Okay? Let's run it. It will bend up there, but not down there, because the same thing should happen on the very top. In other words, rotation about X and Z should, X and Y, and in fact Z should be left alone if that's a cable. So let's check it out. You see, this is not bending. However, on the top, there is a restriction on rotation about X and Y. I don't want that. So if you go back to that, if you go back here, let's deactivate this for a second. If you're putting clamp, you have no control. So let's delete this clamp. Instead, put a user-defined strain. First of all, it's a pin, so no translations at all. And we know that it should not rotate. Rotation should not transmit either. So I'll leave these alone. Same thing with the other one. And I will show you, let me do both of them actually at the same time. I will show you that it will bomb out, and we'll see why. It will bomb out because there's one thing else that we have to restrain. And that is because it's a cable and we just said translation, this can still rotate or spin about that axis. So I have to go back to that point, that restraint, and prevent that rotation about Z or spinning about Z, which is spinning about the Z axis right there. Now it's going to run and it's going to act just like a cable. Done. Okay. So if I activate this and animate it, you will see that this will just stretch down and this will just stretch down without bending. Now I want to repeat this problem, except that I will want to do it with symmetry. So I'm going to kill this job just so that we do it together again. First of all, I'm going to split. See that? We are in assembly design. We are in assembly design, right? You click on the saw, and then you select this vertical plane, and it says that all three of them are affected. Are you sure? The answer is yes. Now, it's, well, let's see what happens. Let's see what happens. This is causing a problem. Okay, so that's fine. No problem. So let's go ahead and do this a different way. What I can do is I can go, for example, to the what is this thing? Where did I create this thing? It was in generative shape design, right? You go there, get the saw there. It says this is the one that I want to split, and the plane is exactly the same one, and this is fine. Okay, that's all right. Now this one we got some kind of error message, but this one we don't have. We can leave it there. There's no problem. It's just that when we mesh it, we just mesh this side. Okay. So we're going to go to generative structure analysis. CATIA sees a 3D object, immediately meshes it. We're going to mesh the shell ourselves. This, yeah, okay, 0.1, 0.2, and give it a thickness. And we're going to mesh it with beam element. Sorry, mesh this line with beam element. Don't mesh the other one because we don't want it to participate, and give it a cross-sectional property. So these are correct because we just used it a minute ago. Actually, what is it that you want to give it properties? This. And what is the orientation point? For example, that corner point will do the job, or that corner point for that matter. Doesn't matter. Everything is the same. Okay, now connections between the end of this line. So let me hide that. You can see steps are all identical, and the corner of that surface. Let me bring this thing to the front. Hide that. If it doesn't let me take it, hide this guy, that corner. This is going to be rigid. Remember, point to point must be rigid. Later on, we're going to come back to that transmitted degrees of freedom. So from the tree, that's the first one we're doing. This, rigid. And then we have between the surface of that and for the second component, that half a circular edge right there. This is going to be fastened, perfectly bonded, perfectly welded. This one, did I do it? Fastened. This. Whoa, there, it's right there. Okay, good. Don't forget the symmetries. So surface slider on this, and these two edges are in plane of symmetry. So user defined, uncheck everything. These two edges, which two edges? This one and that one lies in the YZ plane of symmetry, no translation in X, rotations exactly the opposite. Okay, very good. Did I put a, oh, I need a clamp down here, which I forgot to do. And we need a pressure right up there. And let's run it. You will see that it's going to work, except that that thing is going to bend because those are perfectly. Oh, wait a minute. What did I do here? Something. Let's see now. We must have done something wrong here. Let's just check something for a second. Let's check our mesh. Rigid. Okay, that was this one, rigid, yeah. And this one was fastened. Oh, we forgot to clamp. Okay. Where is that line? We forgot to clamp this line on the very top. That's why it says, hey, I'm not running. Right there. We forgot to clamp this. This thing doesn't lie. I mean, basically, we make a mistake usually, or I make a mistake. Right, right. Okay, so let's look at the deflection. Yeah, okay, you can see it bent. Yeah, good, good. Now, if I want this thing to be cable, then let's deactivate that. So we go to that restraint. First of all, this top, I'm going to make it user defined. No translation in X, Y, and Z, and no rotation about X and Y. I'm sorry, no rotation about X and Y. That means that's not what I meant. Allow rotation about X and Y. About the Z axis, if we don't fix it, that spinning motion is going to cause a problem. So just to convince you, I'm going to uncheck that. I'm going to uncheck that. That's good. And transmitted degrees of freedom, you have to go to properties. That rigid connection, you check on the box, it says, don't worry about rotations. Because we don't worry about rotation about Z here, and don't worry about rotation about Z there, it can spin and it will not run. You'll see. There. Okay, that's because of the spinning motion. So all we need to do, either we go up there, for example, we say no spinning about Z so that it doesn't spin, and run it, and it will work fine. It just stretches. Yep, right there. You can see that. So we have deflection. Change this thing to material shading, and you can animate it. And this thing just stretches. Okay, if it's a cable. So we did this problem with and without planes of symmetry, and this is taken care of. And my other problem, I said that I have two problems for you to do. This was a repeat from yesterday, and here is the other problem. So we have this geometry, and obviously these are clamped, and this is sagging under its own weight. Everything is fully welded, perfectly welded, fully bonded, etc. So these are all, this cannot be a cable because cable cannot sustain a compression. Okay, so this must be actually a beam with all degrees of freedom, not released. Now, this can be done, as I said, either as a single part or as an assembly. I'll do it as a single part. So that's entirely up to you. So let's start with a part file. And I'm going to make that block on the top, this block on the top, which is 4. And I will not use any planes of symmetry. If you were given this thing on the test, you will have to use planes of symmetry. Actually, I changed my mind. I will use planes of symmetry. Okay, so this is going to be, let's see now, 10. This block is going to be, what is that? 4 by 4 by 2, right? 4 by 4 by 2. So let's go ahead and do that. We're going to go into part design. On that vertical plane, I will sketch something that's 4 by 4 and padded by 2 inches. Yeah. So this is going to be 4. I decided to do it with planes of symmetry because you know that on the test, you will be, unless we don't want you, everything has to use all applicable planes of symmetry. And if there's any question, ask. You're in any doubt in your mind. 2. Okay. So what you see here is actually half of this. Okay. Now I need at the bottom, I need a surface. Okay, right? So on that vertical plane, on that horizontal plane, I will sketch. Yeah. A rectangle. We'll clear it up. Okay, so this should be coincident with that. Okay. The dimension from here to here, what is that drawing? That should be 10. Yeah, that should be 10. Exit. There we are. And this is this has to be filled. So I'm going to fill it. So I go to shape, generative shape design, FILL. Okay, so that's this on top of that. And then I need a line here, a beam. So I'm going to create a line, point and direction. So the point is right there. Direction is Z. And you go down by 3 inches. Oh, wrong way. Let's go. Oh, actually, you know what? I'll tell you what I wanted to do. This, it's okay. I can make a line, but I don't need this line. All I need is this line. Okay, so that line is totally useless, but I could have created a point instead. So point to point. Okay, there. This line, I can't delete it because I'm using it, but I'm not going to mesh it. Okay, good. So let's make everything out of steel. There is no everything. This is all a single part, so just make it out of steel. I keep saying that for an assembly, that makes sense, not for part. It's made out of steel. Good. So now we're going to go to generative structure analysis. CATIA sees a solid object, immediately meshes it. It did. You can see that. We have to do the shell meshing ourselves. This one. I'll make this thing 0.2, 0.2, 0.3, 0.2. Okay. Oh, that's too small. I can't even see it. So let's make it 0.4. Oh, that's better. That's better. Okay, and the thickness of this is 0.1. Okay. Oh, wait a minute. What was the thickness? oh sorry, 0.25. If you look at the problem description, it says this thickness is 0.25. And then I have to mesh this thing with beam elements. Okay. And apply cross-sectional properties to it. It says circular, so I use cylindrical beam, radius also 0.25, radius 0.25, yes. We say okay. Notice that I can close it because this is circular. It doesn't need an orientation point, except that I have to select the support right there. You can see that, right there. Okay. We say okay. Good. Now we're going to apply, for example, the conditions that are given. Well, we were told that these ends are clamped. Okay, so let's hide the stuff that you don't want. I don't want to see this. I'm going to hide it. I don't want to see this sketch. I'm going to hide it. Okay, so clamp this end. Okay, very good. On this side, this is a surface slider. Please note that there is some kind of inherent inconsistency or lack of information here, because when I said this is 4, the question is it 4 from the middle surface or top surface? Because these are small, these are thin in our problems, it doesn't matter. But if you're doing this thing for living, then it does matter. You have to do it properly. Okay, so yeah, I'm kind of being sloppy here. Okay, so this edge, this entire edge is in the, as a shell edge, is in the YZ plane, no translation in X. If it's in YZ, no translation in X. Rotations opposite. Okay, that's good. And we don't want this thing to fall. Actually, I'm gonna make it fall, because right now this guy does not realize that there is something holding it. So on purpose, I'm not going to create a connection between them to show you that it actually it falls, goes through it. So here is the, if it's sagging under its own weight, its acceleration on the whole part in the direction Z, negative Z actually. So if the gravity constant, for example, is 9.8, I put down 9.8, it is meter per second squared with a minus sign. Okay, good. And we're going to run it and see that it actually will bomb out. Yeah. And you can see why, because it kind of, they don't see each other. I mean, if you animate it, see that? They don't see each other. Okay, so you say close, deactivate this, assuming, oops, deactivate. Assuming that these are fully bonded or perfectly welded, means fastened. So we create a connection between that face and hide this for the second component, the bottom of this. It created that connection, this line, or actually in the trees right here. And then we make that thing fasten. Fasten is part of the face-face connection property. So it's right here. This is a contact. This is fasten. And we're going to select that. It puts a fastener sign there. And now we're going to run it. And this time it will actually work fine. And this will go down. Ooh, something didn't work. Let's find out what the issue is. Something bombed out. Didn't expect this thing. So let's see what the deformation mode is. Connections. Connection. This corner point and this corner point, and rigid. Okay. Let's do it. Let's take this thing back where it was. So we're going to create a connection between the end of this line and for the second component, the corner of this piece. I'll take my chances and select this, see if it, first, it's got, no, bad idea. Not worth it. So let me hide this. And I want to select this corner point, but I'm not having access to the corner point because this white dot, which is that connection that I'm creating, is blocking my view. So hide it right there. And this one is going to be rigid. Distance connection property. There we are. Because this is not a cable, so I don't have to worry about that. All degrees of freedom are transmitted. And just run it. That's the one thing I forgot to do. And now you see that it just goes down as it's supposed to. Let's check it out. If you're having a problem and can't see much, just change the scale to default. There we are. You can animate it. I mean, obviously, this is a very thick piece of support, and that hinges about it. If you want to look at deflections, and you might say, what about the beam? Why is the beam all zero? It's not zero. If you double click on it and select the beam, you see that the colors will pop up because it's so stiff that we can't see the deflection. Where's the beam thingy? Oh, right here. Yeah, you can see that it actually deflects. So that takes care of the problem that I wanted to do. I did it as a single part. You could have done it in assembly, etc. Good luck.